This video is prepared by Avya Classes. Please subscribe the channel, raise your doubt and watch the video for sure success in JEE, AIIMS and NEET. Discuss some problem based on the concept we have learned. And first problem I have picked from IIT JEE Screening 2002. A particle which is constrained to move along the x-axis is subjected to a force in the same direction which varies with distance x of the particle from the origin as Fx is equal to minus kx plus ax cube, where k and a are positive constant. For x greater than or equal to 0, the functional form of potential energy ux of the particle is. So basically, what should be our approach? That f is given as equal to minus kx plus ax cube, and you have to calculate the form of potential energy. So form of potential energy is what? So as u is equal to, or del u by del x is equal to minus f. So we just write here, as the particle is moving only along x axis, so we just write f is equal to minus du by dx, and f is given as a value, f is given equal to minus kx plus ax cube. So from there we get du by dx is equal to kx minus ax cube, and if I integrate it, we get the value of potential energy, and is equal to u is equal to kx square by 2 minus ax4 by 4. So the value of potential energy is equal to kx square by 2 minus ax square by 4 plus some constants, plus some arbitrary constant which we consider equal to 0. So the value of potential energy will be curved. Now if you see this figure, then you have to first calculate that where the potential energy is equal to 0. So for u is equal to 0, we have the points kx square by 2 minus ax4 by 4 is equal to 0, and take x square as common, then k by 2, in fact x square by 4 take common, then it's 2k minus a x square is equal to 0. So basically potential energy will be 0 at the point x is equal to 0, and at the point where ax square is equal to 2k and x is equal to 2k by a. We have to consider only positive value of x. So these are the 2 points where value of potential energy is equal to 0. Now if we consider, if we take the value of x greater than 2k plus 1, if I take the value of x greater than 2k plus 1, then the term under bracket will become negative and the value of potential energy will be less than 0. So if you see this figure, then only the figure D comply all things, that the potential energy is 0 at a point x is equal to 2k square root 2k divided by a, and potential energy is negative afterwards. Now if what should be the shape of figure, then if you see at x is equal to 0, slope is equal to, or slope of potential energy, that is du by dx at x is equal to 0, we can get, that is minus f at x is equal to 0, and if I put the value of x is equal to 0 in this force, then the value comes equal to 0. That is, the slope of potential energy at origin is a line parallel to x axis. That's why the curve should be in this way. Here the potential energy at x is equal to 0 is equal to 0, and the slope of graph at x is equal to 0 is also 0, that is parallel to x axis. So that's why the graph, the shape of curve in this way. The energy of a system is represented in the first figure. The force acting on the system will be represented by you have given 4 options and you have to find the correct one. So this is basically the potential energies versus x curve. So how we will calculate the force acting on this? So as we know that if we differentiate the potential energy with respect to x, then we get the force. So I just note it down here that the force is equal to minus del u r by del r, and is equal to minus del u by del x I minus del u by del y j minus del u by del z k, that is fx is equal to minus del u by del x, fy is equal to minus del u by del y, and fz is equal to minus del u by del z. That is, if you have to calculate the force acting along x-axis, you just differentiate the potential energy with respect to x, keeping y and z constant. That is, you have to assume y and z as constant value and differentiate the potential energy with respect to x to get the value of fx. Similarly, in order to get fy, you have to differentiate y with u with respect to y, keeping x and z constant. So I just note it down here such that you will come to know here for this differentiation y and z are constant, and so on. So here the potential energy depends only on the value of x, so we write f is equal to minus du by dx, as the potential energy is a function of x-axis only. So if we differentiate it, we will get the value of force. Again, if you see this curve, then first we will note down the equation of this curve. So how we will get the equation of this curve? So what will be the coordinate of this point? So the coordinate of this point can be find out. You have to know the value of this y coordinate also to get the coordinate. And we will leave it. Suppose the slope of this line is constant and we take the slope of this line as k. If we take the slope of this line is equal to k, then for x is equal to or 0 to x to a, this line is equal to denoted by y is equal to kx, where k is the slope of line, and suppose this value is something. If the slope of line is k, then the value of k is equal to tan theta, and that is equal to y by a, and y is equal to ak. So this coordinate will be ak. So, and for x greater than a, we have y is equal to ak. So this is the equation of this line. Now equation of this curve. So if I differentiate this, then for 0 to a, for 0 to a, for x is equal to 0 to a, that is the f is equal to minus del u. This is basically u. So del u by del x, and it is equal to minus kx by x, differentiation of minus kx differentiation with respect to x, and we get the value equal to minus k. So the slope of the value of force must be equal to minus k for the point 0 to a, and afterwards the force must be equal to 0. That is, if I differentiate this, then we get u is force is equal to 0. So f is equal to 0 for x greater than a. So the only curve which is as per the condition, that is f is equal to minus k for 0 to x less than a. In fact, we just take this value, and is equal to 0 for x greater than equal to a, will be the curve C. Now we'll see next problem. A particle moves in a potential region given by u is equal to 8x square minus 4x plus 400 joule, its state of equilibrium will be. So you have to calculate the state of equilibrium when the potential energy is given. So the state of equilibrium, the force must be equal to 0. That is, as we know that for equilibrium, force must be equal to 0, and force is equal to minus del u by del x, or here u is only function of x, so we simply write it minus du by dx. So we will calculate the value of f by differentiating u with respect to x. So minus d by dx, and u is given at 8x square minus 4x plus 400, and it comes equal to minus 16x minus 4. We have to put this value equal to 0, so the value comes equal to minus 16x plus 4 is equal to 0, and from there we get 16x minus 4 is equal to 0, 4x minus 1 is equal to 0, and x is equal to 1 by 4, that is 0.25 meter. So its state of equilibrium is at x is equal to 0.25 meter. That is, answer will be B. Now we'll see next problem, and this problem is from AIPMT 2009. A body of mass 1 kg is thrown upward with velocity 20 meter per second. It momentarily comes to rest after attaining a height of 18 meter. How much energy is lost due to air friction? So if I draw the figure as per this problem, then we are giving it's a velocity equal to 20 meter per second. It goes up to certain height, and the height is here 18 meters, so it goes till height of 18 meter and stops here. So here velocity is equal to 0. In fact, here kinetic energy also be equal to 0, as velocity is 0, and the potential energy will be equal to mgh. So we will calculate the energy at the both point first. So energy at the point A is due to kinetic energy, and potential energy 0 at point A. So we get half into m into v square, and the value is 200 joule here. And if the calculate the potential energy at point B, then it's mgh. M is 1 into g10 into h is 18, and the value comes equal to 180 joule. Here kinetic energy at the point B will be equal to 0. If you see that, then EB is less than EA. So how it is possible? This is possible because some energy is lost due to air friction, and this difference between these two will be the energy lost due to air friction. So EA is equal to energy lost due to air friction plus EB, and we get the value of energy lost in air friction is equal to EA minus EB, and comes equal to 20 joule. So answer will be 20 joule. If you see the option, then option 2 will be correct. So answer will be 2. Now this is our next problem. In the figure shown, the potential energy U of a particle is plotted against its position x from origin. Then which of the following statement is correct? A particle at x1 is in stable equilibrium, or x2 in a stable equilibrium, and similarly C and D options are given. So how we will approach this problem? As we know that for stable equilibrium, however, we have already derived the conditions for a stable equilibrium, unstable equilibrium, and neutral equilibrium. So for a stable equilibrium, the potential energy should be minimum, potential energy should be least. Okay, potential energy should be least for a stable equilibrium. So what is the meaning of least potential energy? That is, if we increase the x or if we decrease the x, then the potential energy should be increased. So consider this figure. If we consider this figure, then suppose at this point x x is equal to x1, we have least potential energy. So if we increase the value of x or comes to the right side of x, or if we decrease the x and comes to the left side of x1, then in both cases potential energy increases. So similarly for the minimum potential energy, we have to pick the point that if we go right or left from this point, the potential energy must be increases. So potential energy must be increased. So if you see this figure, then x1, if I come left side of x1, then the potential energy is still decreasing. So clearly x1 is not a stable equilibrium. Similarly, if we consider x3, then x3, if we come to the right side of x3, the potential energy still decreases. So x3 also will not be in a stable equilibrium. And in this figure at the point x2, if we come left or right side of the point x2, the potential energy decreases. So in fact s2 is a point of unstable equilibrium, and so both x1 and x2, x3 all are not in a point of a stable equilibrium. So answer will be D, none of these. In fact, from this figure we can infer that x2 is a point of unstable equilibrium.